Imagine standing on a quiet beach in Hawaii one evening in 1962. The sky is dark, the ocean calm, and the stars begin to blink into place. Then suddenly, without warning, the night explodes into daylight. A blinding flash splits the sky, and a strange, radiant glow dances across the horizon. For nearly 6 full minutes, the stars are swallowed by a kaleidoscope of colors, as if the heavens have cracked open. It's beautiful, yes, but it's also terrifying. What the people of Hawaii witnessed that night wasn't a natural aurora. It was the result of a high-altitude nuclear explosion known as Starfish Prime, a blast so powerful it created artificial radiation belts around our planet, fried electronics thousands of kilometers away, and forever changed how humanity thinks about space. But why did we nuke space in the first place? And could something like this ever happen again? The answers to those questions lie not only in Cold War history, but also in the hidden vulnerabilities of our modern world. In this video, we'll explore one of the most dramatic and consequential experiments ever carried out in space. We'll uncover the science, the politics, and the unintended fallout, both literal and figurative, that followed. And by the end, you'll understand why Starfish Prime wasn't just a nuclear test. It was a warning. To understand why the US detonated a nuclear bomb in space, we have to go back to a world gripped by fear and rivalry. The early 1960s were the height of the Cold War. The US and the Soviet Union were locked in a tense, high-stakes competition for global influence. Every advancement by one superpower sparked anxiety in the other. After the Soviet launch of Sputnik in 1957 and the historic spaceflight of Yuri Gagarin in 1961, America felt like it was falling behind. Space was no longer just a scientific frontier. It was a battlefield of prestige, dominance, and survival. If the Soviets could put a satellite in orbit, could they also place a nuclear bomb there? That was the terrifying question haunting U.S. military planners. During this time, President John F. Kennedy had to walk a tightrope between demonstrating his strength and avoiding nuclear catastrophe. The arms race had already escalated to terrifying proportions, and both sides began exploring exotic new technologies that could tip the balance of power. Among them, space-based nuclear weapons. The thinking was simple if reckless. If you could destroy your enemy's satellites, blind their missile defenses, or knock out communications, you could win a war before it even began. But before deploying weapons into space, the US needed data. Real data. That's where Operation Fishbowl came in. Operation Fishbowl was a subset of a larger effort called Operation Dominic, which involved dozens of nuclear tests. But Fishbowl was unique. It took the testing beyond the atmosphere. The goal was to understand what a nuclear explosion would do in space. Would it create new types of radiation? Would it damage electronics on Earth? Would it interfere with global communications? There was also a more paranoid reason. What if the Soviets had already developed a space-based nuke? The only way to know what such a weapon might do was to detonate one of our own. So in July 1962, a Thor rocket launched from Johnston Atoll in the Pacific, carrying a 1.4 megaton thermonuclear warhead. That's about 500 times the power of the bomb dropped on Hiroshima. The warhead detonated at an altitude of 400 kilometers, roughly the same height as the International Space Station today. The explosion was captured on film, but what followed couldn't have been predicted. Auroras appeared as far away as New Zealand. In Honolulu, streetlights blew out, radios went silent, and telephone lines sparked. For a few minutes, it seemed like Earth itself was under attack. Starfish Prime was the largest of 5 high-altitude tests. As it exploded over the Pacific, it unleashed a blinding flash of light, followed by a glowing fireball that expanded in eerie silence. Unlike ground-based nuclear explosions, space detonations have no shockwave. There's no air to carry sound. Instead, the fireball morphs into a radiant sphere of plasma that flickers with rainbow-like hues. This is why such explosions are sometimes called rainbow bombs. But beneath the spectacle was chaos. The explosion created an intense electromagnetic pulse, or EMP, that spread across thousands of kilometers. In Hawaii, nearly 1,500 kilometers away, the EMP knocked out streetlights and triggered false alarms. The public was told little about what had just happened, and many assumed it was just a power outage. In reality, they had just experienced the first large-scale effects of a nuclear EMP. The science behind EMPs was poorly understood at the time. Scientists knew nuclear explosions could generate electromagnetic radiation, but they didn't know how far it could travel or how intense it could be. Starfish Prime gave them the answers, and those answers were terrifying. So what exactly is an EMP? In simple terms, it's a burst of electromagnetic energy caused by a sudden release of radiation. In the case of a nuclear explosion, gamma rays ionize atoms in the upper atmosphere, releasing electrons that interact with Earth's magnetic field. This cascade of electrons produces a surge of electrical energy that travels through the atmosphere and can fry anything with a circuit. Imagine a lightning storm that blankets half a continent, knocking out power, disabling communication, and disrupting airplanes all in a matter of seconds. That's the power of an EMP. In Starfish Prime's case, the EMP affected systems well beyond Hawaii. Electrical grids, radios, and even satellites were impacted. The event demonstrated that a single high-altitude explosion could disable infrastructure across an entire region. A real-world parallel occurred in 1989 when a solar storm caused a geomagnetic event that blacked out Quebec. Transformers, overheated power stations failed, and millions were left in darkness. Now imagine if that had been a nuclear EMP, deliberate, calculated, and far more powerful. One of the least understood and most dangerous effects of Starfish Prime was the radiation it left behind. When the bomb exploded, it injected a massive number of high-energy particles into Earth's magnetic field, creating artificial radiation belts around the planet. These belts weren't just theoretical, they were measurable. Satellites orbiting Earth began to fail. Telstar 1, the world's first commercial satellite for television broadcast, was launched just one day after the test. Within months, it stopped working. Ariel 1, Britain's first satellite, also failed. Both fell victim to the increased radiation levels that Starfish Prime had unleashed. These artificial belts persisted for years, adding to the already hazardous Van Allen belts that naturally surround our planet. The event forced scientists to rethink how we design and shield spacecraft. It also led to international concern about the long-term effects of space-based nuclear testing. The shockwaves, figurative and literal, of Starfish Prime reverberated through global diplomacy. Just 1 year later, in 1963, the United States, the United Kingdom, and the Soviet Union signed the Limited Nuclear Test Ban Treaty. This treaty banned nuclear tests in the atmosphere, underwater, and in outer space. The 1967 Outer Space Treaty followed, declaring that space should be used for peaceful purposes and banning the placement of nuclear weapons in orbit. It was a moment of rare cooperation between rival powers, all recognizing that space warfare would threaten not just one nation, but all of humanity. These treaties still form the backbone of the space law today. But like many international agreements, they lack enforcement. And in recent years, old fears have started to re-emerge. Fast forward to today. Satellites govern our GPS, our internet, our financial markets, even the systems that guide airplanes and emergency responders. If even a small EMP were unleashed in orbit, the results could be catastrophic. And here's the scary part. The threat isn't gone. In 2024, U.S. officials accused Russia of developing an anti-satellite weapon that could carry a nuclear payload. If detonated in orbit, it could destroy hundreds of satellites, cripple global communications, and trigger a cascade of orbital debris that would make space nearly unusable for decades. This isn't science fiction, it's current events. We also face natural risks. The sun regularly releases solar flares, and while most are harmless, an event like the 1859 Carrington event could cause global blackouts and disable electronics on a massive scale. That event happened before modern electronics existed. If it happened today, the consequences would be far worse. The lesson of Starfish Prime is both simple and profound. Space is fragile. We tend to think of space as vast and infinite, but the orbits around Earth are already crowded with satellites, debris, and now military ambitions. A single reckless act like detonating a nuclear bomb in orbit could destroy the infrastructure that modern civilization depends on. We need to treat space not as a battlefield, but as a shared resource, a global commons. Just as we protect our oceans and atmosphere, we must protect the space above us. Every generation faces its own set of challenges. Ours is the digital age, and with that comes a responsibility to safeguard the invisible networks that keep our world connected. That includes the satellites silently orbiting above us. Starfish Prime was a warning. Let's hope we're still listening. If you've made it this far, thank you for exploring this critical piece of history with us. If you found this story fascinating, don't forget to like, share, and subscribe. And here's a question to leave you with. If a single bomb in space could knock out the systems we rely on every day, how should we prepare for the future of space warfare? Or better yet, prevent it altogether? Thanks for watching. We'll see you next time.